In our previous video, we learned where an LLM fits inside a Java application. But another important question remains. How does Java actually communicate with OpenAI? Is there a special AI connection? Does Spring Boot directly connect to ChatGPT? Or is it simply another REST API? Today we will answer all these questions. Traditional REST call on left side. When we call a weather service, our application sends an HTTP request. The weather service processes it, returns JSON. Our application reads that JSON, nothing new. OpenAI works the same way. Look at the right side. Instead of asking for weather, we send a prompt. Instead of getting temperature, we receive generated text. Before calling OpenAI, we must identify ourselves. This is done using an API key. Think of it as your identity card. Without it, OpenAI doesn't know who is making the request. The application first sends an HTTPS post request. Example, here it is chat/completions. Exactly like every REST API you have ever used. Then the request body. This is the actual JSON sent to OpenAI. Notice that we are not sending Java code. We are sending structured JSON, where model tells OpenAI which AI should answer. Like here, GPT-4.1, GPT-4.1-mini, or GPT-4o are other models which can be used while answering our query. Think of it like choosing which engineer will solve your problem. Then messages, system message, user message, assistant message. Together they create the complete conversation. This is the server processing. OpenAI receives the request. The selected model processes your prompt, generates text, and returns JSON. Your Java application extracts the generated text. Spring AI hides most of the complexity. It converts the JSON into Java objects automatically. Now, this is the complete flow. Let's summarize. The process starts in the browser. A user enters a prompt such as explain my bank statement or summarize this document. The browser sends an HTTP request to our Spring Boot application. The request first reaches the controller. The controller's job is simply to receive the request and forward it to the appropriate service. It doesn't contain the AI logic. Next, the service contains our business logic. It prepares the prompt, validates the request if needed, and then calls Spring AI. Now comes the important part. Spring AI acts as a bridge between our Java application and the OpenAI. Instead of manually creating HTTP request, adding authentication headers, and parsing JSON, Spring AI does all of that for us. Spring AI then sends an HTTPS request to the OpenAI servers. Along with the request, it sends our prompt in JSON format. OpenAI processes the prompt using its large language model and generates a response. It sends that response back as JSON. Spring AI receives this JSON response, converts it into Java objects, and returns the generated text to our service. The service can now perform additional processing if required, for example, storing the response in database, filtering sensitive information, or combining it with application data. Finally, the service returns the result to the controller, which sends an HTTP response back to the browser. The user then sees the AI generated answer on the screen. The biggest advantage of Spring AI is that it hides all the low level REST API communication. As Java developers, we simply call a Java method, and Spring AI takes care of the HTTPS request, JSON serialization, authentication, and response parsing for us. For interview question, how does Java communicate with OpenAI? A good interview answer is Java communicates with OpenAI by sending HTTPS request containing prompts and model information. OpenAI processes the request, generates a response, returns JSON, and libraries such as Spring AI map that JSON into Java objects. See you in the next video. Thank you for watching.